Hi, I'm Lane Seeley, and I want to tell you about an activity that I've taught several times at Seattle Pacific University, both to introductory physics classes and also with a course I teach in global climate change. And this activity really focuses on appliances for heating and cooling, and then on issues of energy equity and climate justice associated with those appliances. So we start with just recognizing and exploring how important heating and cooling is in the electricity that we use. It turns out that heating and cooling really accounts for the largest share of the electricity that we use in a typical household, which is also shown here. Um, and then once we've motivated the idea of the importance of efficiently heating and cooling, we jump right into looking at the basic physics of how a furnace and a heat pump and an air conditioner work. And so I invite the students to draw energy diagrams, and we at this point in the class we've typically developed a method for drawing energy diagrams, kind of a consensus approach, which we've also provided some resources for with this activity. If you would like to use them to help your students develop an approach to drawing energy diagrams, but there are many different types of diagrams they could draw, and I'll just show you one example of a diagram that kind of captures what's happening with the energy in a very simple way. So here we can see that for a typical electric furnace, you have energy from the power plant as electrical that then transfers to the furnace as electrical energy and then transforms into thermal energy in the furnace. And then once it's thermal energy in the filament in the furnace, it then transfers out to the surrounding air in the house as thermal energy. And then finally, it's going to leak out through the walls of the house into the environment, right? And that's kind of the process that describes the operation, the energy associated with the electric furnace operation. And so then I think about, like, how would we define efficiency for this type of a device, and then also what would we expect that efficiency to be, right? And interestingly, for an electric furnace, the efficiency is essentially 100%, because really all of that electrical energy that you put into the electric furnace then is coming out as thermal energy and eventually diffusing into the environment. So if that's true, though, if the um, electric furnace is basically 100% efficient, then how could we do better than that? Well, it turns out that's where the excitement of a heat pump comes in, because unlike the electric furnace, the heat pump is actually pulling in or pumping thermal energy from the surroundings, from the cold air outside, uh, into the house. So it's not pumping the air in, but it's pumping the thermal energy in that air in, right? And so we spend some time, because it is kind of a complex and really interesting technology. We spend some time looking at sort of the basic physics of how that process works, and then the students get a chance to try to model that with an energy diagram. And I'll just show you. Here's an example of one version of an energy diagram, where you can see that basically the the key difference, there's a lot going on here, but the key difference is that now we have some electrical energy coming from the power plant, but also we're pulling thermal energy from the cold air in the environment, and all of that energy, thermal and the electrical, is being transformed into thermal energy at a higher temperature, right? And that thermal energy is the thermal energy which then heats the house. And so when that heat pump operates, we end up getting a lot more thermal energy out than we have to put electrical energy in. And that's kind of the magic of how a heat pump can be such a sort of a super efficient heating device. Right? And so once we've talked a little bit about the heat pump, we move on to air conditioning. and look at and compare and contrast kind of what a heat pump is doing and what an air conditioner is doing, and students have a chance to draw an energy diagram for an air conditioner. And then I used a film by the International Energy Agency to sort of introduce this idea of the urgent need for air conditioning in many parts of the world as a result of the increasing pressure of climate change. Right? And so that kind of presents this question for them, and then um, and then we talk a bit about climate justice, and specifically describing climate justice as this issue where, for example, the richest 1% of the global population has caused twice as much carbon emissions as the poorest 50% over the last 25 years, and yet it's really those poorest 50% or even the poorest 10% who are going to bear the greatest burden of the changing climate. Right? So those who are least responsible for the changing climate are also those who are bearing the greatest burden. And so then we get it that the students are invited to each review from a whole list of different resources that I've identified, and you could find lots of other resources on this. But basically, looking at the relationship uh, between climate change and urban heat waves and energy availability, and also some of the factors which limit access to affordable and reliable energy to provide air conditioning. So each student then reviews one of these resources and and shares that resource with the rest of the class. And then the students divide into groups of 3 or 4 students per group, and they identify a specific community which is vulnerable to heat waves. So this could be, Aboriginal communities in Alice Springs, which was described in one of the resources, or it could be unhoused communities in, say, Phoenix, Arizona, or even like racially redlined or previously racially redlined neighborhoods in Richmond, Virginia, where the local heat um, heating is much higher than in the surrounding predominantly white communities. And so each group then identifies one specific community, and they work collaboratively to develop a 3-minute presentation, a research presentation, where they answer the questions of what are some of the specific climate challenges that their chosen community may be facing, um, and then recognizing that they won't fully understand the situation in that community just by reading about it. What questions would you ask members of the community to better understand their situation and their priorities? And then what would they think a path towards climate justice might look like in that specific community? And what are some specific strategies or policies which would empower that community to um, to deal with the challenge of climate change? So then they present they prepare those presentations. I'll often have them do it on video, and then we watch them and ask questions and provide feedback on the different presentations. And I really like this activity because it sort of starts with a really interesting scientific question of how is it possible for something to be more than 100% efficient? How does a heat pump even work, and how does it do that? But then takes them all the way to kind of thinking about heating and air conditioning in the context of issues of energy equity and also climate